We've been talking about surface area, and one of the problems that you are going to see on your your IXL, and for sure on your exceeding, if you would like to try that, on game 9, you will see a problem where you have to solve for the missing length when given the surface area. Okay, so when you are given the surface area, we want to utilize our knowledge of finding surface area. So when we find surface area, we need to find the area of each face. So what I'm going to do is I'm going to go through how you would find the area of each face and plug that into an equation. Okay, so the front, okay, what's nice about a rectangular prism again is that the front is the same as the back, the top is the same as the bottom, and the right side is the same as the left side. So the front, to figure out the area of the front, I would take 6 times this length times this width, because that's a rectangle and the formula is area equals length times width. Okay, 6 times x, 6 times x, and 6 times x is just 6x. And I can do that twice because the front is the same as the back. Okay? So I've done the front and the back. Okay? And the reason I'm writing it like this is because I'm putting it into an equation. Okay? The next face we can do is on the side. Okay? Again, it's a rectangle, so we're going to take length times width. So our length would be 12, and our width would be equal, this edge would be equal to that edge, which is x, so 12 times x is 12x. And we can do that again because the right side is the same as the left side, so we're going to do that twice. So we have 6x plus 6x plus 12x plus 12x. The last faces that we're going to do is the top and the bottom of the rectangular prism. Okay? And the length, the edge, that's the length, is right here. Okay? Right there, and that is equal to 12 because this edge is equal to this edge. So we have 12, and for this one we're going to have to do some math possibly. Okay, so we have 12 here, and this edge is equal to this edge, so we have 6 here. So our length is 12 and our width is 6. So we need to take 12 times 6 to get the area of that face, the top face. Well, 12 times 6 is 72, and we do that because the formula is length times width. Okay, 72. So the top is 72, and the bottom is 72, so we're going to do that twice. Okay? If you'll notice, I have 6x plus 6x plus 12x plus 12x plus 72 plus 72. I have 6 different things here because there's 6 different faces. And all of those faces equal the surface area of 252 centimeters squared. 252 centimeters squared. Now our goal is to figure out what x equals. So what we're going to do is we're going to use what we learned when we talked about expressions and equations. So we're going to add the like terms on the left side of the equal sign. So if we add the like terms on the left side of the equal sign, first we're going to split the terms up. Okay? And in order to have a like term, in order to be able to combine terms, they have to have the same variable combination. So these first 4 terms, all have the same variable. So all of them can be combined. So 6x plus 6x plus 12x plus 12x. If you need to do that on the side, you can. But 6x plus 6x is 12. So 12 plus 12 is 24, and 24 plus 12 is 36. Okay? So these 4 were all like terms. Okay? 6x plus 6x plus 12x plus 12x equal 36x. 72 and 72 do not have a variable, which makes them like terms. So 72 plus 72 is 144, and that equals 252 for our surface area. So in order to solve this, it's just a two-step equation. We're going to subtract 144 from both sides. So 252 minus 144, we have to subtract that. We'll get 108. Bring 36x down equals 108. We're going to divide because 36, when a number is next to a variable, it means multiplication. So 36 times x, we want to get the 36 out of there and get x alone. So 36, we want to divide by 36. That cancels because 36 divided by 36 is 1. What you do to one side, you have to do the other. So x equals 108 divided by 36. If you don't know what that is, do it on the side, but I know that it's 3. So x equals 3. So x equals 3 centimeters. Okay? So that's how you create an equation to determine the missing length when given the surface area of a rectangular prism. Okay? That's how you create an equation to find the missing length of a rectangular prism when given the surface area. Okay? If you don't know, or if this was confusing, okay, watch the video again and it will be less confusing. Okay? If you have questions, let me know. Okay, but this video should help you to determine the missing length when you're given surface area of a rectangular prism.